learn and read about them. First off, the definition. A median, it connects a vertex, so it starts at the vertex, and then goes to the opposite sides midpoints. That's why I had you locate the midpoints. So that's what a median does. It starts at a vertex and goes to the opposite sides midpoint. Some special things about it. The medians, when you draw all three, they are concurrent. They should all meet at one point. That one point is called the centroid, and that's what your little chart says, that the point of concurrency is called the centroid. Fun fact, the centroid is actually the center of gravity. So if you put in all your, if I had like, if I had time or whatever, and this was solid, I could draw in all of my medians for this triangle, and wherever all those medians intersected, I could put my finger right there, and it would be perfectly balanced. It's somewhere in here, so I can't. But that is the centroid. It is the center of gravity for any triangle. So if you cut one out of cardboard, we could just put our finger and be perfectly balanced. So it is the center of gravity. So what I want us to do is go ahead and let's draw these medians in and locate our centroid for your triangle. Now, because these midpoints aren't extremely accurate, you're probably going to have to kind of fudge your lines a little bit. So if I draw my first one here and then I draw my second one here, well, I know that my third one needs to intersect here too, so I'm probably going to have to move my midpoint up just a little bit so that it looks okay. So we're just going to have to fudge our lines a little bit. You may have to move one endpoint, but these should be concurrent. They should all meet at the centroid, but this for us is just a quick sketch. That's why it's not going to be perfect. It'll be okay. Just make it look like they are concurrent. This is just a visual for us. Alrighty, on your diagram, we, all of us, are able to put in some marks of congruency. We are able to put in some marks of congruency. There are segments in every single one of our diagrams that we absolutely know are congruent. So I want you to go ahead and label those. Label some sets of congruent segments and be able to justify. I see some of you have your mid-segments drawn in. I did not ask you to draw your mid-segments in there. You should only have medians. You should only have medians. I did not ask for your mid-segments. Your diagram should look extremely similar to mine. Who can raise your hand and tell me some segments that they absolutely know have to be congruent? Carolyn, what's up? Segment AM and segment MB are congruent. I agree with that. But why, Carolyn? Because we drew in the midpoints, and that's by the definition of medians, that it goes from vertex to opposite sides midpoints. We have all of this as a midpoint, that's a midpoint, that's a midpoint. So, is this correct if I put that in my diagram? No, because I don't know if all of those segments are congruent. So make sure you differentiate your sets of congruent angles. So just straight off the bat, because we have our medians, we know we've got a lot of congruent segments. But now what we need to focus on is how is this centroid, and we're going to call it point Q. We're going to call it point Q because C is already taken down here. So Q is just an arbitrary number or arbitrary letter. I just picked it out of a hat. But we may want to write Q, point Q is the centroid, just so when you go back and look at this diagram, you'll know what you drew. And Q is the centroid, and this has everything to do with your medians. Alrighty. Now look at your centroid. For everyone, it should be point Q. Do you see how it breaks every single median into two parts? The centroid splits every single median into two parts. Do we see that? Do you notice that one piece is larger than the other piece? Okay. This centroid is very unique, and it breaks these medians up into two parts, and the larger part is always going to go from the vertex to the median. This is always going to be the larger part of the median. It's going to go from vertex to centroid. And this is actually 2/3 of the whole length of the median. It will always be 2/3 of the whole length of the median. So what does that leave left over for the distance from centroid to the midpoint?
1/3.
1/3. This is how the pieces are related to the whole median's length. This is how the pieces are related to the whole. Now let's start comparing the pieces. So what I want you to do is think to yourself, do not yell anything out loud, just think to yourself. How is this piece, how is this length related to this piece, this length? And once you figure out that relationship, then, well, what if I told you this distance was x? How could you represent this distance of this other median then? So first, ask yourself, how are the pieces related? We know how they're related to the whole. This is 2/3, that's 1/3 of the whole. Now we need to think about, how are these two related? Are they congruent? Are they equal? What is... And once you figure that out, then please answer, represent this, the length of segment AQ, represent that in terms of x. So if this was x, then what would this have to be? So this is you're thinking on your own, please not yell anything out. Who thinks they got it? So how is this piece, length of segment BQ, how is that related to the length of segment QP? So if I said the length of segment BQ is equal to QP, how are these related? What would I have to put right in front of this? A what? A 2. So what are you saying then? If we place a 2 in there, then what are we saying? Twice as much, right? Okay, we know how thirds work, right? Fractions, we know how thirds work. So I have 3 markers here. So if 2/3 of my markers are here and 1/3 of my markers are here, I'm asking you to relate these two parts. How many more markers do I have in this hand compared to this hand?
Like double.
Twice as much. Twice as much. So that's how these pieces are related, that the larger one is going to be twice as big as the smaller one. And that makes sense, because if I have 1/3 here and I have 2/3, that's twice as much. Twice as much. So my shorter piece is x, and how can I represent, in terms of x, how can I represent this length? 2x. Same exact concept, but just a little different perspective. What if I told you that this length was y? How could you represent the length of segment MQ?
2y.
So if this was 10, you saying this is 2y, that would be 20? That looks a whole lot shorter than the other one. So I'm giving you the bigger piece. So how could you represent the smaller piece? 1/2. You would have to divide by 2 or multiply by 1/2 to get the smaller piece. So what we're going to do with this diagram is we're going to practice a little bit. We're going to practice. So what you should have on your piece of paper right now is this lovely triangle, and inside you should have all of the notes, like the 2/3, the 1/3, and twice as long, and so on and so forth. Alright, so this is what you should have, along with the writing and the notation. I'm going to put up on the board 5 scenarios. Now, every single one of these scenarios is completely different. So yeah, you got it, bro. Every single one of these scenarios is completely different. They are not related to one another. So you're not going to use information from number 1 to help you out with information, or sorry, to help you out to solve number 2. So if I told you that the length of segment AN is 12, then what would AQ have to be? And so these are all different scenarios. So I need you to the left, to the right, below, somewhere, you need to write these 5 scenarios. We're going to write these 5 scenarios. We're going to solve for these missing lengths. So write these down and we'll go over them together. Write them down first, quickly. So for length of segment A, I'll do one with you. The length of segment AN, which is the whole median, if that was 12 units long, then that would force, what do I ask you for?
AQ.
AQ. Then that would force AQ to be what? Well, I give you the whole, and I know that the length of segment AQ is 2/3 of the whole thing. So in mathematics, what does the word of, what does that mean? Multiply. So then you need to have this length is equals 2/3 of multiply the whole thing. So what's 2/3 of 12? 8. Make sure that when you use your calculator for fractions, you're putting each fraction in its own set of parentheses. You have to put each fraction in its own set of parentheses. Alright, so go ahead and knock out these 5 and we'll regroup and we'll talk about them.